Hello, welcome to clickshare.com. This video is the second part of two-part series on first sorted value function. If you have not seen the first part, then I would recommend you to go through the first part, which covers the technical aspects of the function and also the logical expression processing. So let's get started. So let's quickly jump into the second slide. And in the second part, we will look at some practical scenarios with the examples on where the first sorted value can be used. So let me jump to the next slide. Okay, so here are some of the scenarios. Now, obviously there could be many more scenarios, but here are some of them I can think of. So the first scenario is get the latest field value based on timestamps. You're looking at stock and you wanted to get what is a closing stock, so you can use the first sorted value function, and then you can use your timestamp as sort weight field and you can get the closing stock. And then if you wanted to calculate biggest customer for each product category, so which customer bought maximum number of units, or probably which customer spent most money on a specific product. And we also can use the first sorted value function to calculate the minimum and the maximum value, and we can extract a related field. So when I say minimum and maximum value, all I mean to say is if you don't specify any number within your first sorted value function as a parameter, you will obviously return the first value. However, if you wanted to return last sorted value, then you would use the minus sign and you will flip the expression. So I'll show you some examples, so don't worry about them now. And we can also use it to compare the first highest score versus the second highest score. So you can see what's the difference between the first highest score and second highest score, and that's pretty useful. And finally, I'm sure most of the Excel users who come from the kind of an Excel background would wanted something like a VLOOKUP, but VLOOKUP based on a minimum or the maximum value. So that's exactly what first sorted value can do. Based on a specific field, you can calculate the minimum and maximum value, and you can extract the relevant field for that value. Probably you might not grasp everything at the moment, but I'm sure I have some examples, so with the examples you will have clear understanding. So let's jump back to ClickView and then let's look at some practical examples. Okay, now let's look at the script. Control E. So I have a script and I have a simple view, and I'm calling the view from SQL Server. So let me reload this. So let me reload this document and let me add a new object, and then let me add a table box. Okay, and then let me move the customer key as the first field. Click on OK. Let me expand this so that you have complete view of the data. So I have data here, and now using this data, I'm going to talk about 4 or 5 practical scenarios where we can use the first sorted value function. So let's say the first requirement is we have to find the customer key who has the highest consumption. So let's add 2 fields, consumption and customer key, obviously. So we have 2 fields here, and we also have a table here. So let's say that we wanted to identify the customer key who has the maximum consumption. So let's click on new and then select text object. So I'll probably use the text object to write the function, so that makes it easier. Then select first sorted value, brackets, and we wanted the customer key, yes. And then we wanted the sort weight field to be consumption. Close the brackets. So if I select this and press OK, we get 18365. So if I sort this by consumption, we get 18365, but it is not the highest value, it's the lowest value. So if I go back to expression again, and if I add the minus sign before consumption as a prefix and then click on OK, and now let me sort it in descending order. So now you see that 182 is the customer key who has the maximum consumption. So that's pretty straightforward. So let me copy one more instance of this object, and I'll change the expression so that I can save myself from typing. So let's say the next requirement is we wanted to find the gender who has the highest average income. So we have a gender field here, and we have the yearly income. So we wanted to know which gender, is it male or female, who has the highest average income across our data set. So to do that, I'll probably go ahead and delete this bit, and then we wanted gender as an output, so yes, gender. And now we wanted to aggregate the data, so that we wanted to aggregate the data to see if it's male or female. So we'll use the agree function, and then I'll say average is the function, yearly income is my field, and then my dimension would be gender. So I'm grouping everything by gender and calculating the average for yearly income, and then close the bracket again. So before we go ahead and close the bracket, let's also add the minus sign, because we wanted to get the highest value. So it says that it's female. So if I change this, I'm sure it should say male. Yeah, pretty straightforward. Okay. To prove that the female is the right value, I'll quickly create a chart object, and then we can look at a table and then see if it's right. And then let's say same expression, agree, and then we don't need agree, we can say average yearly income, finish. Okay, let me sort this. Obviously 57,369 is the average income for female gender, so that's fine. So we have the right expression, and so it's pretty useful to use the first sorted value to actually extract the expression or the field based on a specific calculation. In the first expression, we've used first sorted value, and then we have just used two field names. And in the second expression, in fact, I've used an agree function and aggregated the data, and based on the aggregation, we are getting a specific field. Now let's take this a step further, and then let's calculate something more interesting. So again, we wanted to fetch the customer key who studied bachelor's degree and also aged above 70 years and who has the highest compensation. So again, I'm going to remove all this and then click on this button so that we can have full view. Okay, now we need the set expression because we wanted to filter only customers whose educational qualification is only bachelor's degree. So I'll say education, and then oops, sorry, forgot the bracket, set modifier bracket, and then education equals to, and then close the set so that I don't forget the flower brackets, and then I'll say bachelor's, yes, and then comma. Now let's say age equals to, again close the bracket so that I don't forget them, and now I'll say that age greater than 70 years. Okay, that's done, and now let me go ahead and close the bracket. and my field name itself, I wanted customer key, yes, and that's based on consumption again, and that should be the highest consumption, so I'll say minus sign at the beginning, close the bracket. Okay, so we get 2327. So this is the customer ID who has studied bachelor's degree and also aged greater than 70 years, and obviously he has the highest consumption. So let's go ahead and check if we've got this right. So I'll add age, and then I'll add education as my fields. Okay, so I'll select bachelor's degree, and at the same time I'll go ahead and select age greater than 70, and then this is the customer number 2327. So if I clear the selections, I still get 2327, so which is pretty straightforward. And now let's take this a step further and make it more interesting. Let's add a table, and then we'll calculate probably 3 different expressions by using the first sorted value. Let me add new sheet object and then click on charts, and then I'll select table, click on next, and then I'll select my dimension as gender and educational qualifications, so we'll have 2 dimensions. Okay, I'll not type any expression, I'll just click on finish. Okay, we don't see any data, that's fine because we don't have any expression. Now we're going to type the expression. So in the first expression, we wanted to calculate highest consumption across our data set. So who has the highest consumption across our data set, which is what we have already seen, it's 182. So let's go ahead and say first sorted value, and then let's select customer key comma minus consumption. So if you see, we should be getting 182, but we haven't got it because my function works based on dimension. It doesn't work based on overall set or the superset. So let's go back to properties, and so we've already seen adding set modifier, and we've already seen how to perform aggregation in here. So now let's use the total qualifier. So this should give me 182. Oops, no. Okay, let me see, there's something wrong. Okay, sorry about that. This should be consumption. It's not customer key, obviously. So consumption, I'm sure it should give me the right value now. Yes. So irrespective of what dimension we are at, irrespective of what we see, we get 182 because that's the customer key who has the maximum consumption across our data set. Okay, next let's just taking this a step further and make it more interesting. We wanted the highest consumption across the educational group itself. So we want the highest consumption based on educational group, but not based on gender. But we still wanted to see the gender here. So let's go ahead and add the expression. This should be interesting. So first sorted value, I'll select total qualifier again. Oops. And select customer key and consumption. So we wanted to get the maximum consumption, and we have the minus sign. Now this is same as previous expression, but we have to add the dimension group. We wanted to group it by, so let's select education here, and then close the bracket. Okay, now if you see, across everything 182 is right, but across bachelor's degree it's 291, and then graduate degree it's 182, and then high school is 1170, so on and so forth. And you will see the same numbers for female and same numbers for male, because we are just grouping by education and we are not grouping by gender. So let's select some random value. Let's select high school, and let's see which is the highest value. 1170 is the highest value, which is right. Okay, so now Let's go back and then let's write one final expression, and then let's keep it simple so that we can see the difference between the three expressions. So let's select first sorted value again, and I'll select customer key and consumption again, and let me expand this. So now if you see, 182 is common across all the three expressions. However, the first one is ignoring my dimensions and it's getting whatever is highest across my superset. And in the second one, we are just grouping by education but ignoring the gender. In the third one, if you see, I'm also including gender and also looking at people who are female and who have bachelor's degrees. Then I'm calculating the highest consumption and then getting their customer ID to prove that I'm right. So let's select female, and probably let's look at graduate degree. So female, made the selection, and then graduate degree, and then I get highest consumption is 3436. Let's clear the selection, and I get 3436. So you can use the first sorted value function in variety of scenarios. You can use the first sorted value function in many scenarios. You just need to be clever and creative on where and how to use it. So I hope I've covered all the aspects of using the first sorted value function. However, if you have any questions, please drop me a note and I would definitely try my best to get back to you and answer the question. So thank you for watching. Have a good day.